So now we have two results here. One is called covariance, measured in units of square feet times dollars, and the other is correlation, which has no units of measurement. Before I say more about what this number tells us and how it can be interpreted, I would just like to point out that there's a slight difference in the results, whether you use the function correl or the way I've just defined it. This should not bother us. This is due to technicalities which make no difference for understanding what we are measuring here. For the interpretation of the correlation, it helps a lot if we draw a scatter diagram of this data. And use the information about the mean and the standard deviations for both to split that area here that we see. Here's the lot area, a living area, here's the price, into 4 segments. And I'll show you how to do that. So we know the mean of the living area is about 1700, which would be here, and the mean of the sales price would be about here. So we get 4 segments here, and we should notice that those 4 segments have a very special role. We see up here we have all the cases where both the sales price and the living area are above the mean. We have down here in the left lower part all those cases where the living area is below average and the sales price is below average. Here we have cases where the living area is above average but the sales price is below, and here we have the living area below mean and the sales price above the mean. And now for computing the correlation coefficient and interpreting it, it is essential to understand what drives the final outcome is the dispersion of the data points across those 4 segments. And that will be then the common dispersion. We ask whether the dispersion has some commonalities here. And when we compute the product of deviations from the mean for each pair of observations, and then compute the average of those products, we summarize the information here, because you should notice that if we find 2 deviations from the mean with the same sign, so both above the mean or both below the mean, the contribution to the covariance or contribution to the correlation is both positive. Whereas if we have cases where the living area is above the mean but the price is below the mean, we get a contribution which is negative, as we get when we have a living area below average but the sales price above average. So entries in this column here of the products of the deviations from the mean would be positive for any values in the plus plus segment or in the minus minus segment, and entries would be negative for all the cases with the plus minus and minus plus segment. And as usual in statistics, what counts is kind of average. So if we average these numbers and the average we get is positive, it must be the case that observations or pairs of observations in the segment minus minus and the segment plus plus, those observations dominate that average. Whereas there might be a few in the minus plus plus minus segments, but those negative entries do not make such a difference here, and the overall result becomes positive. The average becomes positive, and so does the correlation coefficient. So a correlation coefficient which is positive indicates that you have a dominating pattern in the sense that cases are distributed in a way that we have cases where both the living area and the price tend to be above their means or tend to be below their means together. And that is the core for understanding the sign of a correlation coefficient. In order to understand the magnitude of the correlation coefficient, it's of course important how the scatter actually looks like. So if we consider this value up here, which would not be exceptional from a sales price perspective, but given that price and given that rather large area, it looks exceptional. And that value is the one that we find here. Suppose that would be a typo or whatever, and that value would actually be 1600 rather than 1500, 5600. We would see that the scatter looks different now, and the correlation coefficient goes up. Now, why is that the case? Well, the pair that was driving this result used to be a pair with a negative contribution, a large negative contribution, because we had a case where the living area was above average and the sales price was below average. And so that would make the correlation eventually smaller. And if that was different, we would get still a negative contribution, but it would not be that large. So the covariance would increase because that contribution is not that negative as it used to be, and the correlation coefficient goes up. So in other words, for the magnitude of a correlation, it really does matter how far the individual observations deviate from their mean and the overall tendency. Now suppose we would replace the information in the living area by using, for instance, information month sold. Put that here. We get a correlation coefficient which is close to 0. And the scatter of points now, as you see, has no clear pattern. All the 4 segments are more or less equally populated with the data points, and consequently the correlation becomes close to 0. So to summarize, the correlation coefficient measures the common dispersion of 2 variables, and if those 2 pairs tend to show up in the way that both are on the same side of their mean, that will be same side, both above the mean, both below the mean, correlation will be positive. If the pairs would show up in the way that they would be on the opposite side of their means, like plus minus minus plus, the correlation would be negative. And the magnitude of a correlation coefficient depends on the extent of that tendency to be stable. In other words, how many exceptions we find to an overall rule. Like here, we have a tendency that we find both on the same side of their means with a few exceptions only. And that major exception here makes the correlation coefficient rather small. If that had not been there, it would have become larger. So the correlation is a measure for common dispersion driven by patterns of deviations from the mean, has no dimensions, and is bounded between -1 and +1.